Sahara Desert experiences first-time flooding in decades. Scientists on alert. How can there be a flood in one of the biggest deserts in the world? Well, you are in for a surprise. Torrential rains transformed parts of the Sahara, creating temporary lakes and rivers in a region defined by its dryness. This stunning occurrence not only captured global attention, but also raised critical questions about climate dynamics and the increasing role of extreme weather in reshaping iconic landscapes. To understand how and why such an anomaly happened, let's explore the science behind the flooding, its impacts on ecosystems and communities, and the broader implications for our changing planet. What exactly happened? What does it take for one of the driest places on Earth to turn into a watery spectacle? In August 2024, a perfect storm of atmospheric and climatic factors converged to bring torrential rains to the Sahara Desert. Imagine regions accustomed to receiving a mere trickle of rain suddenly inundated with enough water to fill rivers and create temporary lakes. This was no ordinary weather event, it was a dramatic meteorological anomaly. According to NASA's Global Precipitation Measurement (GPM) mission, a series of atmospheric anomalies in August 2024 caused an exceptional downpour in the northern and central Sahara. These rains, described as intense and widespread, were a result of moisture-laden air masses moving unusually far north due to shifting weather patterns. Satellite imagery captured the stunning transformation of the desert, with temporary water bodies forming in regions that haven't seen significant rainfall in decades. News coverage highlighted the event's sheer scale, reporting that some areas received over 100 millimeters, nearly 4 inches of rain in less than 48 hours. To put this into perspective, the Sahara typically receives less than 25 millimeters, 1 inch of rain annually. This deluge was not just a drizzle, it was a full-scale downpour that overwhelmed the desert's sandy soil, which is ill-equipped to absorb water quickly. The science behind the floods. The flooding of the Sahara Desert in 2024 was a result of a complex and fascinating interplay of atmospheric and climatic factors. One of the most significant contributors was an atmospheric river, a narrow but powerful corridor of concentrated water vapour in the atmosphere. Often referred to as rivers in the sky, these atmospheric rivers can transport vast amounts of moisture from tropical regions to other parts of the globe. In this case, an atmospheric river carried moisture-laden air far into northern Africa. As this humid air mass reached the Sahara's cooler and drier atmosphere, the moisture condensed, leading to heavy and sustained rainfall. Another critical factor was the unusual behaviour of the jet streams, which are fast-moving air currents in the upper atmosphere. Jet streams usually act as barriers that confine weather systems to specific regions, but during this period, the jet streams shifted southward. This shift allowed warm, tropical air filled with moisture to penetrate deeper into the desert. This convergence of tropical air and cooler desert conditions created the ideal environment for an intense and prolonged downpour. Warming oceans added yet another dimension to the equation. Rising sea surface temperatures in both the Atlantic Ocean and the Mediterranean Sea have increased the rate of evaporation, pumping more moisture into the atmosphere. This amplified the intensity of the atmospheric river, effectively supercharging the rains that fell over the Sahara. The connection between ocean temperatures and atmospheric moisture is a well-documented phenomenon, and in this case, it played a pivotal role in the scale of the flooding. Lastly, climate change has likely influenced the occurrence of such extreme weather events. While it's difficult to attribute any single event solely to global warming, the overall trends of rising global temperatures are disrupting established weather patterns. Climate change has been linked to more frequent and severe anomalies, including shifts in jet streams, enhanced atmospheric rivers, and extreme precipitation events. The Sahara floods serve as a reminder that the impacts of climate change are not confined to coastal regions or polar ice caps. Even the world's most arid deserts are not immune to its effects. Impacts of the flooding. Ecological transformation. The sudden and intense rains brought a temporary revival to the Sahara's otherwise barren ecosystem. Dormant seeds, which had lain in the sand for years, began to sprout into lush greenery almost overnight. This transformation turned parts of the desert into unexpected patches of life, complete with blooming plants and grasses that provided food and shelter for small animals. The pools of water created by the floods acted as oases, attracting migratory birds and other wildlife. Species that rely on wet habitats, such as amphibians and insects, appeared in these areas, adding to the diversity of the ecosystem. However, this revival was short-lived, as most of the water quickly evaporated or was absorbed into the ground, leaving behind an altered landscape. Despite its fleeting benefits, the deluge posed significant challenges. The force of the water caused soil erosion, washing away layers of sand and exposing rock formations. Additionally, flora and fauna that had adapted to the desert's arid conditions faced disruptions. Some plants, for instance, were overwhelmed by the sudden water, leading to localized die-offs. Such events highlight the delicate balance of desert ecosystems and their vulnerability to sudden changes. 2. Human communities. For the human populations living on the edges of the Sahara, the floods brought mixed fortunes. In many cases, the rains replenished aquifers and wells, providing much-needed water for drinking and irrigation. Farmers saw an opportunity to cultivate crops in areas that had been too dry for agriculture, and herders welcomed the temporary increase in grazing land for their livestock. However, the floods also brought destruction. In some regions, the sheer volume of water overwhelmed infrastructure. Roads were washed out, homes were damaged, and essential supplies were delayed or cut off. Villages in low-lying areas bore the brunt of the damage, with some families losing their homes and possessions. CNN's interviews with local residents captured the complexity of their experience. One farmer described the rains as a blessing and a curse, a moment of hope for the future, but also a source of immediate hardship. Relief efforts were hindered by the remoteness of the affected areas, leaving many to rely on their own resilience and community networks to recover. 3. Geomorphological changes. The Sahara's landscape has been shaped over thousands of years by wind and occasional rainfall, but the 2024 floods introduced rapid and dramatic changes. Temporary rivers, called ephemeral streams, carved deep channels into the sand, redirecting the flow of water and creating new pathways. In some places, the erosion was so severe that it exposed ancient sedimentary layers, offering scientists a glimpse into the geological history of the region. The formation of temporary lakes also altered the terrain. These water bodies, though short-lived, left behind mineral deposits as they dried up. Such changes can have long-term effects on the desert surface, influencing wind patterns and the movement of sand dunes. In the aftermath of the floods, researchers observed changes in dune formations, with some areas appearing more stabilised due to the moisture content in the sand. These geomorphological changes are not just a curiosity, they also have practical implications. Altered landscapes can affect navigation and land use for both humans and animals. For instance, newly formed channels and lakes may serve as natural barriers, forcing communities and wildlife to adapt to the new geography. The 2024 floods offer valuable insights into the Sahara's ancient climate history. Thousands of years ago, the region was a lush savanna with abundant water bodies. Events like this remind us that the Sahara's current state as a desert is not a permanent fixture, but a phase in its long climatic journey. Moreover, the floods serve as a stark warning about the unpredictability of a warming planet. As global temperatures rise, extreme weather events are becoming more common, even in areas traditionally considered stable. The Sahara floods highlight the interconnectedness of climatic systems and the urgent need for global action to mitigate the effects of climate change. This event provides an unparalleled opportunity for scientific research. Studying the desert's response to such a sudden and intense influx of water can improve climate models and enhance our understanding of how ecosystems adapt to rapid environmental changes. These lessons could prove invaluable as we prepare for a future where such extremes may no longer be rare. The 2024 Sahara floods were a powerful reminder of nature's unpredictability and the profound interconnectedness of our planet's systems. This rare event transformed one of the world's most iconic deserts into a fleeting oasis, offering both awe-inspiring beauty and sobering lessons. While the floods temporarily relieved people and ecosystems, they also underscored the vulnerabilities of our changing climate. As the Sahara returns to its familiar arid state, the memory of its brief encounter with water lingers as a testament to the ever-changing nature of our world. It is a call to action to better understand, protect, and adapt to the forces shaping our planet. The Sahara's story of resilience and transformation reminds us of the delicate balance between survival and change in the face of nature's immense power.